Good morning, good afternoon, good evening, wherever you may be. Thank you for joining. Welcome. My name is Aaron. I'm one of the solution engineers here at HashiCorp. And in today's webinar, I want to provide an overview of how you can utilize HashiCorp Boundary in a private cloud vSphere environment context. Because there's a misconception that the HashiCorp portfolio is heavily focused on public cloud usage and ephemeral workloads like Kubernetes. However, my background prior to joining HashiCorp was centered on private data centers. When I started to begin learning the HashiCorp technologies, I often thought about how invaluable tools like Terraform and Boundary would have been when I was a virtual infrastructure administrator. Now, a few months ago, I ran a session on HTTP Packer for creating and managing vSphere templates and on building virtual machines from those templates using Terraform. If you haven't seen that session, we'll provide a link as Eric alluded to in the chat. It's not essential for today's presentation, but I do encourage you to watch afterwards. We will send it in that email after today's session. But today's session really builds upon that topic by exploring how we can access the VMs we provision in our vSphere environments, because we know that setting up your applications to be secure is just the first step. That's basically day one. But there's always going to be other challenges you're going to face in day 2, day 3, day 259 of keeping your application secure and reducing your risk profile over time. So let's reintroduce our two personas from last time: Anita, our virtual infrastructure administrator, and Scott, our developer. This time, Anita has started to gain some experience with Terraform and has started to build organizationally approved modules. These modules enable internal developer teams to efficiently build infrastructure that are for the private data center. This allows Scott, our developer, can now easily spin up virtual machines tailored to his needs with those predefined Terraform modules that are available to him. However, despite the streamlined provisioning process of building a VM, Scott can't readily access his newly created VMs. So let's examine the process Scott needs to follow to access his newly deployed workloads. Scott is usually located in a corporate network, although this could be the public network. And this is a target virtual machine running in our vSphere environment. And so this machine's probably, sitting on some type of secure private network where he probably needs some type of access, whether that be SSH, RDP, or even general TP access of some kind. So Scott faces several challenges when attempting to access that new deployed VM. He could either have direct network access, and this would mean the VM is on a network to which Scott would need direct access, which is uncommon in most secure environments. Another option could be having direct vCenter console access. So this is where we would need to require specific permissions and network access to the vCenter console. It's not user-friendly for daily development tasks. It's generally not granted to developers due to security concerns. And so this is a pretty uncommon approach as well. The most common pattern we see is a combination between a corporate VPN, which is difficult to set up and maintain, and it can become a bottleneck for performance and throughput. It may not provide the granular access controls needed. And then also on top of that, you have some type of jump server or bastion host. There's complexities in this flow because it's not the best user experience for Scott. Scott's jumping between servers where he may or may not have all the tools he wants to use for working with that target workload. It requires careful control of what users can do with that machine, and it normally involves some type of manual life cycle of the SSH keys for those credentials. They're usually long-lived. So from a security perspective, the developer connects to a machine that can also have access to other machines on the same network, which increases our risk of lateral movement within the network. And those long-lived credentials, if they're leaked or stolen, they can have severe consequences and probably keeps our security administrators up at night. Operationally, if a single host or a single bastion host becomes a single point of failure. And if we start to think, well, we'll grow this out, as our organization grows, more developers like Jane and Bob join the team. And like Scott, they need respective access to their virtual machines. So while Scott might be wanting SSH access, now Bob needs RDP to his virtual machine, and Jane may need specific Postgres database access on port 5432. This expansion introduces several additional challenges. So setting up and maintaining multiple developers just naturally makes it more complex. Ensuring that developers have the appropriate permissions and without over privileging the is difficult. Each developer may require access to different VMs. So now our Bastion needs access to different networks. And if developers need access to different ports, that means we need to open more firewall rules. If that Bastion host or hosts experience some type of downtime, then our developers lose access to their VMs. That Bastion host effectively becomes a gateway to multiple sensitive areas within our network and infrastructure. And then when you start to track and audit who's doing what, it just becomes more complicated. This is all to say the traditional access method for Scott, Jane, and Bob impacts their productivity and the organization's security posture. So this brings a crucial question that we have to ask ourselves in the organization. Can we improve the VM access model? So Boundary is a modern privileged access management solution built for today's world where resources are generally dynamic. It provides a consistent experience for users to securely access their resources if it's in public cloud or in our private data center. Administrators can pre-authorize users to access target resources based on their identity and limit users from accessing other resources in the network. Workflows are automated and streamlined for both the end user and administrators, making it simpler for the end users to access their resources and less touch points from the administrators to maintain over time. With Boundary, end users no longer need to handle those credentials or those resources, those long-lived credentials, reducing the potential for a breach. Instead, they can have a passwordless experience and use something like Vault to dynamically provide a short-lived credentials, rendering those credentials useless if they're exposed. We often see Boundary being deployed for use cases where you want remote developers to access Linux or Unix type of systems. Maybe a site reliability engineer needs access to production environments in a break class scenario, so very short periods of time, or temporary access to a contractor that's coming in to do a specific bit of work. So let's take a look at what the workflow could look like through HashiCorp Boundary, where we can reduce the complexity of access and have a better user experience for our developers. This time, our developers are going to authenticate into Boundary. Users need to authenticate themselves into Boundary to validate their identity. Boundary supports OIDC and LDAP and therefore works with the majority of the providers, Okta, Ping, ADFS, Entra ID for authentication. Once we're authenticated, through policy, we are given roles that permit the type of access and who we can connect to. So these are predefined resources set by the administrator, like a specific set of Linux machines or Windows machines or a database or even a Kubernetes cluster. And this is the significant difference by using our identity to provide what specific access we are granted. Once a connection has been authorized, Boundary provides access into the network via a tunnel. It can manage the credentials on behalf of the user, including those dynamic short-lived credentials from Vault. And it establishes that end-to-end connection for the end user. The main area to focus on here is that this isn't one way to provide access. This is about one pattern to provide a variety of access with fine-grained control in mind. On top of that, Boundary allows us to do auditing of who did what. We can do SSH recording, and the user can leverage the tools that they know and love installed locally on their laptop as if they were directly connected to the network that particular target machine was on. So let's have a look at this through a demonstration. So what you're seeing on my screen right now is the Boundary user interface where I can see what targets I have access to through my machine, through my identity. I can see that I have an on-prem virtual machine with an alias of Windows-VM HashiCorp.local. I can see that I'm currently connected to it, and if I look at sessions, I can see that session available. I can click on that session and see now I can connect to that machine with some credentials that Vault have generated for me into the Boundary client. So I can see the username and the password. If I copy that username and I connect to an RDP session, I can paste in the password. Oh, let me copy that again. Paste in the username and password. Click continue, and I'm off to the races. I am accessing a virtual machine that's sitting inside my vCenter environment that only I can connect to because I'm provided the access through Boundary and those generated credentials from Vault. So that's one scenario of a pre-existing target machine that I may have access to, but I only have one machine available to me right now. Let's go and build some new workloads and do a full end-to-end flow as if it was Scott, Jane, or Bob. So I'm going to open my Visual Studio Code now, and I have two directories. I have a Ubuntu-based vSphere virtual machine and a Postgres machine that is also in vSphere. I'm going to execute the Terraform apply command just to get us running and get started with building this infrastructure, and then I'll show you what's actually happening under the hood. So we execute Terraform apply. This is going to go build our Ubuntu machine in Terraform Cloud. And I'm going to go execute a Terraform apply on this side, and this is going to build us our Postgres machine through Terraform Cloud as well. So we'll drop the terminal down to the bottom and have a look at what the code is actually doing. For our Ubuntu virtual machine, I have a little bit of Terraform code. Now, this is the modules that Anita, our virtual infrastructure, has provided Bob, Scott, or Jane. In here, I have a module called Ubuntu VM, and this is just specifying the module that it can use. Really, for the nature of this conversation, is just providing a bunch of parameters that are required for this module to specify how I can build a vSphere virtual machine inside my environment. What's also cool is that I've also got a boundary module, and this module uses the outputs from our vSphere virtual machine module and passes them in so that this user can automatically get access to the virtual machine through boundary, where we get that identity approved governance and control, but they are none the wiser in relation to all the setup and configuration. In here, I'm just specifying maybe the project, which is a boundary logical construct to say who can access what. Maybe specifying the host name and address of the machine that I want to connect to, and the services I want to access. In this example, I'm specifying that I want to have SSH access on port 22. If I have a look at the Postgres Terraform code, it's very, very similar. I'm building a virtual machine through a module called Postgres VM. I'm passing in the parameters for that virtual machine. Maybe I'm using a DNS record to register that machine as a DNS record. And then again, I specify the boundary Postgres target module. In here, I'm just specifying the exact same similar information. This example, where I want this machine, rather than give the user access to the machine via SSH, I can actually specify an individual port in the Postgres database that they can connect to, which in this example would be 5432. So if we go over to vSphere, we can see in the recent tasks, I pop that so I can see. Oh, if I can see in the recent tasks, we can see that those two VMs that I executed through the Terraform plan and apply are starting to build. So they've cloned off a template, they've done their reconfiguration, they've done their customization, and now they're powered on. So you can see our original Windows VM that we were connected to, but we now have our Ubuntu VM and our Postgres VM that we built through Terraform. If I go back over to our command line, just to make sure that the actual execution is built, our Ubuntu machine is still being built, but we can see our Postgres machine has been built, and it's now created a target inside Boundary. So if I go back over to our Boundary client and I click refresh, we can see, there we go, our two machines are now built. So our Postgres database and our Ubuntu virtual machine. So now, just as building a virtual machine infrastructure via module, I can access those machines via modules as well in Terraform. If I want to now see what it looks like to connect, all I have to do is click on the connect button, and now I'm going to connect to my Ubuntu machine and get some generated SSH credentials just to that machine automatically for me using Vault as my identity broker to make connection to credentials. So Boundary Client also has a native shell. So if I click on shell, I can see that I'm now automatically authenticated to that particular machine that we just built. It had an IP address of 172.21.14.34. If we go back to our vCenter console, we can see that that Ubuntu machine hopefully has the same address, 172.21.14.34. So I know I'm on the actual machine that I just built through Terraform, and now I have access through that Boundary module. If I click on targets and go back to our machines, you'll notice that I used an alias for when I was connecting to the Windows machine. For a Postgres machine, I can also click connect to this and generate some credentials to connect to a particular database rather than the virtual machine itself. In this example, I'm going to use this the 127.0.0.1 address, and Boundary has the ability to give me a specific port that I specify, so maybe 5432, or I can get Boundary to dynamically generate a new port that is specific for that connection. So I can copy that particular random port. I can open a tool natively on my laptop like PG Admin, and I can go register that server. So if at this time I go Postgres VM, I specify the connection. So I do 127.0.0.1. If I could type. I specify the port that Boundary gave me, and now I just need to give it the username and password. But again, Boundary has been able to generate those credentials for us. So I copy the username, I copy the password, and there you have it. I am now connected to that particular database, not the virtual machine, on port 5432, and I can see that I'm connected with this account that just got generated for me. So I can now do my developer configuration natively on my laptop with my developer tools, but still having remote secure access to those machines based on my identity. So while HashiCorp Boundary enhances the security in many ways, what I want to focus on is how it addresses the risk associated with unfettered access and exposure to long-lived credentials. There's three main categories that we focus about from a business value. Boundary enforces the least privileged access by granting users only to the resources they need when they need them. Traditional methods like firewall rules and IP restrictions are ineffective in dynamic environments where we're building virtual machines constantly through our day. Boundary, especially when integrated with Vault, eliminates the need to handle those static credentials scattered across our insecure locations. From a speed perspective, security often slows down workflows, but Boundary actually improves both the security and the velocity. By removing the burden of credential management and abstracting that network complexity, users no longer need to track their IP addresses or worry about the securing of the credentials. From a cost perspective, cost comes in many forms, not just monetary, but I guess Boundary reduces the time and effort required to deploy, manage, and have user access solutions compared to either custom, bespoke, homegrown, or other commercial products. And so that's it for the presentation today. If you have any questions regarding this presentation, please reach out afterwards. I'm more than happy to discuss.